So welcome to the webinar. We're going to talk today about in-house emergency response, specifically the post-fall rescue and retrieval side of fall protection. We're going to talk about that because falls are a significant problem in industry. Falls injure thousands of workers every year, and in fact, they killed 2.2 million people worldwide last year. The Fall Protection Symposium that was held in Baltimore last month had a presentation by a guy named Carl Hines, and Carl gave an excellent presentation on the status of fall arrest and fall protection in industry worldwide. During that presentation, he presented some data on how many deaths there are per year, and it's really quite astounding and a little depressing. There are 500 fatalities in the United States resulting from scaffold and ladder incidents alone. Now that's a pretty staggering statistic in itself. And we know that falls account for about 19 or almost 20% of all non-fatal occupational injuries involving days away from work. So days away from work are pretty darn expensive for the employer, and deaths are obviously pretty catastrophic for people on all sides of the fence. So we want to resolve falls, and part of resolving falls is the fall protection system itself, and the other part of resolving falls is recovering from the fall or the rescue after the fall. In case you're not convinced that falls are really a problem, you can see from this chart that the actual number of fatal falls has really not improved since 1992. In fact, it's gotten worse. We're actually seeing more fatal falls in 2007 than we were from 1992 to 2004. The number of fatal falls from height are about 71% of those. So, or in 2002, they're up to about 75% in 2007. So the number of fatal falls from height are not decreasing. If anything, they're increasing or even staying steady. So we need to improve the response to falls in industry. You've probably seen on television scaffold incidents such as this one. This is an incident that occurred in June 2009. In this particular situation, there were two workers on a scaffold, and they were wearing fall protection equipment. They were safetied into their systems, and in fact, when the scaffold failed, they did fall into their arrest systems. You can see that one of the guys is hanging there, holding on to his line, trying to gain some sort of comfort. They were eventually rescued by the fire department, but unfortunately, it took about 60 minutes for that to happen. An hour is an awfully long time to hang in suspension in a rear attachment point if you've never done that. This is an incident that occurred in Portsmouth, Maine in 2010, actually last month. It was a fall from a bucket truck. Bucket trucks, like scaffold, are a serious type of incident where accidents happen a lot, and we're not improving our statistics there either. This particular incident was non-fatal. It was a serious injury, but it's an example of places that we need to work to protect falls. On June 10th last month in Pennsylvania, this was a fall from a natural gas drilling rig. The fall was only about 20 feet. A lot of you guys have probably jumped 20 feet or even stumbled 20 feet and lived to tell about it. Unfortunately, this guy didn't. He fell a mere 20 feet and he died from his injuries. This is another fatal fall that occurred just this year. This was in a meat packing facility, and unfortunately this guy fell about 70 feet. He also died from his injuries. Falls are a really serious thing, and falls continue to happen, and we need to stop the falls, and it's the employer's responsibility to do that. The employer's responsibility for safety at height includes fall protection, including rope access or whatever types of methods he wants to use. And it also includes post-fall rescue planning. There's an internal response as well as an external response side of that, and we're going to talk about all of that today. The employer's obligations are completely outlined by OSHA, and they exist for both construction and general industry. In the construction side, you'll see 1926-502 actually identifies some of the fall protection requirements for construction. Fall protection for general industry is addressed in 29 CFR 1910. And for scaffolds and aerial lifts, there are specific requirements. For poles, towers, and similar structures, there are similar requirements. And for all of those, there's a requirement for first aid and timely response for rescue. So we're going to kind of go into a lot of that today. I'm not going to go into very much in the fall protection side of the house. Hopefully you know that part. If you don't, certainly give us a call, and we'll see what we can do to help resolve that. But the bottom line we want to talk about today is that wherever fall protection is, or wherever fall protection should be used, rescue preparation has to go with it. So we're going to talk about the rescue preparation today. In 1910.66 and in 1926.502, regulations for general industry and construction both say that the employer has to provide for, quote, prompt rescue of employees in the event of a fall, and the employer shall ensure that the worker is able to self-rescue in the event of a fall. So there's provision there and a requirement there for the employer to make provision for his people. Prompt rescue is sort of a term that is difficult to define, and so people have written to OSHA in the past and asked for interpretation on exactly what prompt rescue means. In interpretation letters, OSHA has defined that the word prompt means that rescue has to be performed quickly. Well, prompt and quickly are both kind of subjective, but it's further clarified by the statement, in time to prevent serious injury to the worker. Well, what does that mean? It means something different depending on what kind of work you're doing. If you're working, you can see in the April 2004 interpretation letter at the bottom there, it says that employees exposed to electric shock at fixed work locations have to be reached within about 4 minutes. Now that's the employee has to be reached within about 4 minutes. When you have a worker at height that has to be reached within about 4 minutes, that's a pretty tough thing to do. We also have to think of it in terms of what our capabilities are as far as getting rescuers to the patient. Chief Johnson of the IAFC put this out 2 months ago in May 2010. He put out a letter that said, technical rescues are high-risk but low-frequency events. The rarer the incident type, the more likely that fire and EMS personnel may be unaware of, unprepared for, or even forget proper procedures as they race to rescue a victim. And this was put out as a warning to rescuers that they need to be prepared in the event of a rescue or for whatever kinds of rescues might occur in their area. But in addition, it should be a warning to you as an employer to say, hey, is my local emergency services really prepared for the kinds of rescues that I might have? The other thing that we have to take into account is the fact that the economy is hurting rescuers and emergency services personnel just like it's hurting you and me in business. Thousands of firefighters across the country, according to USA Today, are facing possible layoffs, prompting concern that deep local government budget cuts will delay emergency response times. We're actually seeing things blamed on that already. We're seeing that responses have been slowed to fires and to other incidents, and so it's something to be aware of as an employer. The other thing we need to keep in mind when we think of timeliness response and quick response is the potential for suspension intolerance. I'm sure you've all heard of suspension intolerance and are probably familiar with it. But the bottom line with suspension intolerance is that people hanging motionless suspended in a harness can experience very bad results, even death, within a very short period of time. You can find research on this collected by Paul Seddon in a 2002 report that was published by the UK Health and Safety Executive, and the ISBN number is posted there if you'd like to research it. There was also work done in France that I'm not even going to try to pronounce, but other work that was done by NIOSH. Nina Turner and a group of people at NIOSH did some work on suspension tolerance in a full-body safety harness, and you'll see that their results basically said you needed to have somebody rescued within about 12 minutes. The OSHA Safety and Health Bulletin was put out in, I believe, 2002 maybe. Maybe it was 2003, but that Safety and Health Bulletin also said that according to all of the research that's been done, anybody who falls into a harness should be rescued quickly. You can find guidance for this in the new ANSI Z359.2 minimum requirements for a comprehensive managed fall protection program. ANSI Z359 is a document that was initially published in 1992, and then it was republished again in 1999 without much in the way of changes. In 2007, ANSI Z359 was rewritten to address requirements for fall arrest equipment for general industry. Construction is actually addressed by A10, and A10 is working on documents as well. But the ANSI Z359 family of standards was republished in 2007 with not just the Z359.1 safety requirements for equipment, but also a point 2, which is minimum requirements for a comprehensive managed fall protection program. The minimum requirements for a comprehensive managed fall protection program encompass all aspects of your fall protection program. And if you're looking for help in writing a fall protection plan for your site, Z359.2 can really help you out. In fact, Z359.2 actually includes some of the considerations for rescue after a fall as well. There are other chapters in Z359 now as well that might be useful to you, but the only other one we're going to touch on today is Z359.4, which is safety requirements for assisted rescue and self-rescue systems, subsystems, and components. So again, you'll find the equipment requirements in Z359.4 and the procedural requirements or the process thinking requirements in Z359.2. As we pre-plan for rescue, we can think about the pre-plan in terms of personnel, rescue, and equipment. Your pre-plan should include personnel preparation for both internal and external responses. It should include rescue plan for non-entry and entry procedures, and you should address all of your equipment as well in terms of both equipment or effectiveness and compliance with whatever regulation it is that you need to comply with. We're going to talk about all of these individually, but we're going to start with personnel. When we think of personnel for rescue, often we think about our rescue plan being 911. Unfortunately, we really shouldn't consider our entire rescue plan to be 911. 911 or calling emergency services is really not a sufficient rescue plan. It can be part of your rescue plan, and in fact in 1926 subpart M it actually addresses the availability of rescue personnel as an emergency services organization, and it says that you as an employer need to think about what technical capability, what medical capability that emergency services might have, and how those can be implemented in the event of a fall. So think about your external personnel in terms of what they have available and what they can offer you. They need to be familiar when you're working with your external personnel. They need to be familiar with your work site and your methods. They need to know what kind of systems you have on site. They need to know what your fall hazard analysis looks like. What kinds of falls might you have employees exposed to? What kinds of, you need to know what kinds of emergencies that response agency is capable of responding to. What is their maximum potential response time to all areas covered? If you're working on a large site or even a small site, it might take a certain amount of time for them to get to your front gate, but it's probably going to take them a little bit longer to actually get to where your suspended worker may be hanging. Your workers need, or your emergency service personnel responding from the outside need to be familiar with the equipment on site. If you're using fall arrest blocks or other types of systems, if you're in confined spaces, if you're in a chemical atmosphere, whatever your equipment is, that emergency services needs to be familiar with what that is so that they know how to make a good plan to get the person out. Sometimes emergency services organizations have a requirement for advance notice of certain types of work. Not all emergency services organizations are well equipped or well funded to be able to have all types of response capabilities at all times. So if you're going to be doing an especially difficult or hazardous type of work, it's a really good idea to just let them know in advance. I'm going to be doing confined space work this week, or I'm going to be working in a chemical environment this week, and then that way they know to be specially prepared. It's also good for you as an employer to know what kinds of methods your response agency is going to use to rescue personnel if in the event of an incident. As an employer, it really is ultimately your responsibility to ensure that your employees are well taken care of. And then how is that emergency services organization going to maintain their ongoing capability? So don't discount 911 as an emergency response capability or as an emergency response plan, but it shouldn't be the entirety of your plan. You should also have internal personnel or internal capability for rescue. In order to accomplish that, you need to know how many exposed workers might you have at any given time. What type of work are they going to be doing? Are they going to be doing work inside of a confined space? Are they going to be doing work at a very high height? Are they going to be at 70 feet? Are they going to be at 20 feet? Are they going to be using ladders to access and egress a site, and then they're going to have handrails? All of those kinds of things play into what kind of internal hazards you might you might be experiencing. What other kinds of hazards might be on site? Are there chemical hazards on site? Are there animals? Are there wildlife? Are there snakes on site? That's one of the things we're seeing in the wind turbine industry is some of the places that these turbines are being put up. We have hazards that you don't necessarily think about inside a normal plant. And then what are your skill levels of your workers? What kinds of capabilities do they have? Have they had their 8-hour fall arrest or fall protection class and that's all they've had? Or are they, like the guy on the right, a skilled rope access worker who has the capability to not only rescue himself but a couple other people? Anybody working at height, anybody at all working at height, really needs to have at least some basic training. The basic training for work at height needs to include the self-rescue capability. Self-rescue should start with attaining a position of comfort. If you've ever fallen in that rear attachment point in your full body harness, you know it's a pretty uncomfortable place to hang. When you're hanging in that rear attachment point, you're kind of turtled. You're in a reverse sort of way. You're kind of hanging forward. Your diaphragm's compressed. You're not hanging in a very comfortable position for your back. You can't really reach anything. So learning how to get at least a position of comfort so that that person can breathe and think about his next step is really the first step in basic training for an exposed person. The second step is, how do I get myself out of this predicament? Getting oneself out of a fall arrest predicament really requires having the equipment and the capability on themselves at all times. That means that it has to be equipment that they either carry on their harness or have with them, or it's even part of their emergency, or it's part of their daily operational equipment. And they have to practice with that equipment on a regular basis. The other thing we need to think about is coworker rescue. The reality is that coworker rescue or a fall incident to a worker is almost more dangerous to his coworkers than it is to himself. When a guy falls in a harness, he's got guys next to him who have been working with him for the last year or 5 years or even 6 months, and those guys aren't going to stand by and wait and just see what happens. They know that guy. They know they had lunch with him yesterday. They may have had a barbecue with him last week. They may know his wife. They may know his kids. They're going to be worried about him, and they're going to try to do something about it. If they're not properly trained to do something about it, they're going to cause more harm than good. So what should those coworkers do? Those coworkers need to be prepared and trained in advance so that what they do is simple and automated and safe. This is an incident that happened in Texas last year. It was a fall into a 1,500-gallon tank where a coworker tumbled into the tank, and people just didn't know what to do. They hadn't really pre-thought about it. So a coworker said, well, hey, there's a tank and there's stuff in it, and there's a guy in the stuff. The best way to resolve this issue is to get the guy out of the stuff. And so he cut a hole in the tank. Well, the tank was full of ethyl methyl bad stuff, and so that wasn't necessarily a good thing. By the time the incident was resolved several hours later, 7 employees and 3 EMS responders were hospitalized. And 7 employees and 3 EMS responders were hospitalized because there was a lack of a pre-plan. If there had been a pre-plan in place, this didn't need to turn out this way. Contrast this with the construction industry in 2009, same month, where an incident occurred. This is an actual incident, an actual picture of the anchor on the incident. It was a roofing accident, which happens all the time. The guy was caught by his fall arrest system. It was less than a 2-foot fall. He was left hanging suspended by his SRL, but he was rescued by a coworker in less than 5 minutes and returned to work later that day. So we know that by pre-planning, successful things can happen, and there can be a successful response to a fall. The other thing you might want to think about in terms of personnel or internal personnel is having standby rescuers. Standby rescue is kind of an expensive proposition, and it's really only justifiable where there's a significant probability or consequence of an incident. But it does provide for on-site trained personnel with a lot of equipment to do very complex rescues. So normally you use standby rescue where there's a high probability of a really bad thing happening and where you need advanced technical rescue capability. Our goal is to have a response or have a solution or resolution of the incident within about 10 minutes. Regardless of what kind of systems you use, whether it's self-rescue or internal rescue or external rescue, we need to have well-established rescue procedures. Again, going into the Safety and Health Bulletin that OSHA put out in 2004, they addressed that, that suspension intolerance is a very real problem, and that suspension in a fall arrest device can actually result in unconsciousness followed by death in less than 30 minutes. So rescue and treatment should occur as quickly as possible. This is exemplified by an OSHA reported accident. Its accident number you can see there, where an employee died while he was suspended in a safety belt. He was using a simple wood seat assembly attached to a descent control device, and he was wearing a safety belt and a lanyard, and he was attached to an independent lifeline, so he was doing a lot of things right. But when he went over the parapet wall, he didn't hook things up properly, and he fell. He only fell about 6 feet. He was successfully caught by his safety belt, but he was unable to be rescued within a short period of time. He didn't have the wherewithal to self-rescue, and the local emergency services was unable to get to him before he expired, and he died of asphyxia due to the safety belt compressing his lungs. So suspension intolerance is a very real problem, and it actually has resulted in death, even here in the United States. As we look at rescue procedures, we need to think about whether we want rescue procedures that involve an entry or non-entry type of response. A non-entry response is where the coworker doesn't enter the hazardous environment. The coworker doesn't enter any kind of a situation where he too might get into trouble. This is the preferred method for lesser trained personnel. Entry type rescues are really only appropriate for rope access type people or people who have extensive training. The other thing we want to think about is minimizing the amount of training that a coworker needs in order to maximize that response capability. The person who's working at height obviously has a real job, and his real job probably isn't rescue. So maintaining the ability to do a simple rescue without having to spend a lot of time every month practicing it is a really good thing. The systems that the person should use, the rescue systems and rescue procedures that the person should use, should really be fail-safe in orientation. They should be something that the guy can't easily make a mistake. We need to think about avoiding suspension intolerance. We need to think about releasing the fallen party from his fall arrest system, and then think about the route to safety. If you're working over a vat of ethyl methyl bad stuff, or even a big tank of water, or the ocean for that matter, thinking about whether you need to go up or down or sideways in order to get that person to safety. Rescue procedures need to start with emergency escape or emergency egress from whatever kind of situation the person might be in. Having multiple avenues of escape is a good idea. For example, the guy on the left is in a wind turbine, which is fine to come down the inside of a wind turbine as long as the turbine itself isn't compromised in fire or chemical exposure or something like that. But in the event that it might be compromised, it's good to have an outside response capability as well. Rescue procedures should also include non-entry capabilities for coworkers. This is a situation where the coworker can reach down and rescue the worker without getting himself into any kind of a hazard at all. In this situation, you can see him reaching down with a pole to connect the coworker to a safety system to then be hauled into safety. There is also entry methods for coworker rescue. The entry methods need to be practiced on a regular basis. We really avoid any kind of exposure to height for workers who aren't trained and don't practice this kind of system regularly. But where they do have the chance to train and where they do have the chance to use the systems on an ongoing basis, it's a good idea to practice those. And we always encourage not using knives, but having a haul system to get the patient out, or the victim, out of his suspended condition. So coworker rescue entry methods should be practiced on an ongoing basis. And then finally, professional rescue, where professional rescuers have to be called in for a rescue. If those people can practice those techniques on an ongoing basis as well, that's a very good thing. But know what the rescue procedures are going to be, because again, as an employer, that's really your responsibility. In considering rescue procedures, we also have to think about the medical considerations. What happened to that person to cause him to fall? Was it a simple slip or trip and he's just hanging in his suspension system, in which case the main thing you might have to worry about is suspension intolerance and the effects of that? Or might there be other considerations at play? Might it be an older worker who's compromised medically from for example, a heart attack or a stroke? Or could it be an on-site, did you have on-site chemicals where the person might be exposed to bad air? So think about all of those things and how you're going to respond to whatever the medical consideration might be. In pre-planning your equipment, we think about OSHA again. We think about equipment that allows the employees to rescue themselves. So first and foremost, we want them to rescue themselves after a fall. And usually that involves equipment that have a descent capability. So you can see on the left an emergency escape system. One of the things that we think about in terms of emergency escape systems is that the emergency escape system has to be carried on the worker at all times, or it has to be available on the site at all times. If the guy falls and the emergency escape system is hanging 20 feet above him, it's not going to do him a whole lot of good. So it has to be small enough, compact enough, available enough to be with him when he needs it. We also have to think about operational considerations. When we're thinking about rescue after a fall for a worker, we don't want to think about putting a lot of parts together to create an emergency rescue system. We want to think about having an entire system pre-planned, pre-put together as an entire solution so that all the worker has to do is put it into place and make it work. I think of this as in plug and play. We want them to simply go clip, clip, and do the rescue, not have to figure out where to put 14 carabiners and 3 pulleys and a lot of other equipment. The equipment has to be applicable to the work site. If you have high heat, for example, or if you have certain kinds of, well, your height, if you have a 300-foot height exposure and a 100-foot evacuation system, it's not going to do you a lot of good. How many workers are there? Are you able to rescue them all? So it has to be applicable to the work site. It has to be compact enough so that it's there when you need it. Ideally, it should be purpose-built for exactly what you're going to do with it. It should be customized to your application. It should be very simple to use so that that worker can put it into place and utilize it without a lot of extra training or repeated training. And it should be fail-safe in operation so that even if he does make a mistake, people aren't going to plummet to their death. But again, I can't emphasize enough the systems approach to rescue. We need to think about complete solutions, complete rescue systems, not parts and pieces. Operationally, for equipment, your escape system is going to be different from your coworker system, or your coworker rescue system, and that's going to be different from your professional rescue system. Your escape system is going to need to be small and compact and available and on the worker when something happens. Your coworker rescue system might not be on the worker, it might just be on site and easily accessible within a couple of minutes to the coworker. The professional rescue system is probably going to be more complex, and it's going to involve several more parts and pieces and probably more personnel, and that's okay, but think about how different the equipment should be for each one of those kinds of operations. In terms of compliance, I would encourage you again to look at ANSI Z359.4. This is a standard that the employer has to comply with for the employee. It's not a standard that is really applicable in any way to emergency services responders. Emergency services responders fall under other standards such as ASTM or NFPA. The ANSI Z359 is specifically for the employer, but equipment that's used by the employee for self-rescue or assisted rescue should be compliant with ANSI Z359.4. When you're pre-planning, again, remember your personnel, your rescue, and your equipment. So personnel is internal and external people. Your rescue is rescue procedures, both non-entry and entry. And your equipment needs to be thought of in terms of effectiveness and compliance for whatever type of work it is you're doing. Emergency egress and rescue systems is not just for falls. This was an incident that also occurred last year, relatively close to my neck of the woods, where an employee was buried in grain. If he had simply had a safety system on, even though it was not a fall that caused this to happen, or he didn't die as a result of the fall, he was buried in grain. And again, with a pre-plan, that just didn't need to have happened. This was another incident that happened this year in San Diego. Burn injuries were received by 2 workers at height, and they had to be lowered and rescued as a result of that flash. So it's not just for falls that we need to think about rescue, but we might need to be rescued or have rescue available for other reasons as well. In 2007, this was a confined space incident that happened where a fire resulted in a blocked exit. These people did not fall. They didn't fall to their deaths, but had they had a rescue system in place, they would not needed to have died. Also, something to think about is that OSHA is considering changing some of the rules. OSHA has put out a new rule change proposal for 29 CFR Part 1910, and you can access that at the link down at the bottom of the page there. OSHA is thinking of changing rules to reflect current industry practices and national consensus standards. They want to harmonize provisions with other OSHA provisions. So, for example, the construction regulations are very different from some of the other standards in even their own counterparts. So there's 2 parts of 1926, for example, that kind of conflict with one another. They're trying to change that sort of thing. And then also they want to use performance-oriented language wherever possible. So rather than saying in order to be safe at height, we expect everybody to use equipment that meets a certain standard, they want to begin saying, you know, a person needs to be capable of these certain things in order to stay safe at height. So I would encourage you to access that proposed rule change at the OSHA website or at the link that you see there below. And it's out for public comment right now. I think public comment ends in late July or early August, and so now is your opportunity to put in whatever recommendations or thoughts that you might have regarding that rule change. I thank you for your time today, and thank you for being here. The work at height, rescue after a fall problem is one that is receiving a lot of attention from OSHA right now. In fact, falls from height are one of OSHA's top 3 priorities for 2010, and we expect to see rescue after a fall a considerable part of what they're looking at. So I would encourage you to pay attention to that for your industry. If you have any questions, feel free to type them into your chat box down at the bottom of your screen, and I'll try to address those today. Or you're welcome to contact me by email or telephone at the numbers that you see there above. And again, don't forget to access that OSHA proposed rule change and make comments on it. Jessica, back to you.
Alrighty, let me just switch my screen here. Alrighty, hopefully you guys can see that. And, we're going to start the question and answer session now. So if you have any questions, you can type them into your little box on your control panel that says chat/questions. And right now we do have one question up there already, and it's do the fatalities listed in the falls from height include HIP or HIP?
I'm sorry, I'm not familiar with HIP. Can you expound on that, please?
Harness-induced pathology.
Thank you. Yes, well, yes and no. They may, and unfortunately, right now, we don't classify falls in a very logical sort of way. For example, the suspension death that I showed earlier in the presentation, that wasn't found under OSHA falls. When I went and searched the OSHA website, I accidentally found that. It was listed as death by asphyxiation. And I just happened to trip across it. And so it really wasn't even called a fall from height death. It was called a suspension or an asphyxia death. So that's a problem right now in the way that we're classifying things. And so things, they may include harness-induced pathology, and they may not include harness-induced pathology. It's impossible to say right now.
All right. Well, that was actually the only question that we've had so far. So if anybody else has any questions, go ahead and type them in right now. Otherwise, and I'll get to them after I'm done with my little ending spiel here. But if you have further questions that you think of after the presentation is over, or you come up with something, you can feel free to go to the link, and there will be a button on there that'll send you to Louie's email. And you can also download the presentation, the slides, and you can watch the live recording of the webinar with the audio. And then also, we're doing these webinars once a month, so it's the first Tuesday of every month. The topic for August has not been decided yet, but mark your calendar for August 3rd at 12 p.m. There will be another webinar going on, and you can, again, go to that same link and see the topic. It should be posted within the next week or so. And we also have a Facebook and Twitter account where you can follow us or friend us for news and updates, and we update that quite frequently, so it's an interesting thing to keep track of. And we have a few other questions now. The fall the young guy took in the belt that rode up and crushed his chest, causing asphyxia, wouldn't be classified as HIP surely. Are there any recorded instances based on current views on what HIP is?
The one that I am most familiar with, the one that kind of launched a lot of this stuff, actually happened in Norway, and I don't remember the exact incident. It's buried here on my computer somewhere, I'm sure. But as far as the deaths from that, no, we don't have a sick code. OSHA, as you probably know, has sick codes for everything, and there isn't a sick code for that. So it would have been harness. It probably would have been listed as harness-induced pathology if there was any such sick code, because what we classify as harness-induced pathology is pretty broad range right now. There's not a nice, clean, where does asphyxia begin and harness-induced pathology end? They kind of merge together somewhere in the middle, don't they? So no, there really isn't a good classification anywhere, and as a result, there's no way to find whether there have or haven't been, or what they might be. What we do know is that if we artificially put people into those kinds of situations, very bad things begin to happen to them in a very short period of time.
Okay, and we just had actually a comment from somebody that could help clarify. He said that he's a paramedic, and when they have a fatality from a fall, for instance, it's listed as a death by head injury.
Yeah, very good point. And that's exactly the crux of the problem right there.
And that is all the questions that we have right now. So again, if you have any further questions for Louie, go ahead and go to that link. There will be the button will be up this afternoon, and the slides and the video of this presentation will be up sometime tomorrow afternoon. So thank you all for coming. The other thing that I'd like to add is just that if you're attending these webinars, we're getting pretty good attendance on the webinars, but we are not really sure what kinds of subjects you guys want to hear about. So if you have suggestions, go ahead and send those in, and let us know what kinds of things you'd like us to talk about, and we'll find speakers on various subjects and try to get you the information that you're most interested in. Yeah, that'd actually be really great. So if you have any suggestions, please. My email is jwyderko, it's jwyderko @pmirope.com, and I'll also put a link to that on this website up here. And you can shoot me an email on if you want any specific topic or a range of topics. Please let us know. We really are doing these for you guys. So thank you all for coming. We really appreciate your attendance, and thank you, Louie, for doing this. All right. Thanks for your time. See you later.